Welcome back, everyone. Today we are going to explore the foundations of calculus by deriving the derivative of the standard sine function y equals sine of x from first principles. Let's break down the math step by step.
We begin with our baseline function. Let y equal sine of x, which is our equation 1. Next, let's introduce small increments to our variables. If x changes by a small amount delta x, then y will change by a corresponding small change delta y. This gives us our second equation. Y plus delta y equals sine of x plus delta x.
Now let's isolate our change in y by subtracting equation 1 from equation 2. This yields delta y equals sine of x plus delta x minus sine of x. To turn this difference into a product, we apply the standard sum to product trigonometric identity. Simplifying the angles leaves us with 2 sine of delta x over 2 times cosine of 2x plus delta x over 2. To transform this expression into a rate of change, we divide both sides by our independent variable increment, delta x. This prepares our equation for the limit process. Let's apply the limit as delta x approaches 0 to both sides. The left side resolves into our derivative notation, d over dx of y. On the right side, we separate our limits. We manipulate the terms to align with our standard limit theorem, which states that the limit of sine of x over x as x goes to 0 is exactly 1. Evaluating our limits, the special sign limit reduces to 1, and substituting 0 for delta x simplifies the cosine term directly to cosine of x. Multiplying it out gives us our final result. The derivative of sine of x with respect to x is strictly equal to cosine of x. Thank you so much for joining today's session. If this first principles breakdown helped clarify the calculus behind trigonometric derivatives, hit that like button, subscribe, and share. See you next time.